You spend 3 weeks training an AI on your workflow, your brand voice, and your data. Then, Monday morning, it looks at you like a total stranger. This is the goldfish problem. Despite having the collective knowledge of the internet, most large language models have the functional long-term memory of a housefly. Even with the current industry standard, called RAG, AI still struggles to remember the context of a conversation that happened just a few days ago. But a new shift in architecture is quietly moving us past simple search and paste into something much more human. True, hierarchical long-term memory. To understand where we're going, we have to look at where we are. Currently, we use RAG, or Retrieval-Augmented Generation. Think of it like giving the AI a library card. Instead of the AI trying to memorize the whole world, it searches a database for specific snippets of text related to your question and pastes them into its brain right before it answers. It solved the problem of AI hallucinating or making things up, but it created a new one. It treats every piece of data as a flat, disconnected sticky note. It can find the what, but it usually misses the why and the when. This sticky note approach fails miserably when things get complex. If you ask a standard RAG system to analyze a financial trend across 5 different 100-page spreadsheets, it breaks. It sees individual rows, but it loses the structure. It's like trying to understand a skyscraper by looking at a pile of individual bricks. Recent research is highlighting that this flat retrieval is the bottleneck keeping AI from becoming a true professional partner. We need a system that doesn't just read words, but understands the architecture of information. Enter hierarchical memory indexing. This is an emerging architecture where the AI doesn't just search a giant pile of data, it navigates a map. Experimental frameworks, some even projected in research for the coming years, are using a multi-stage approach. First, the AI finds the right building, then the floor, then the shelf, and only then does it read the page. By filtering out unnecessary data before it ever starts reading, the AI can handle thousands of tables and documents simultaneously without getting overwhelmed or losing the thread. But memory isn't just about storage, it's about management. Engineers are now borrowing a concept from robotics called SPLM, simultaneous planning, localization, and mapping. Think about a robot vacuum. It doesn't need to remember the exact position of every dust mote it ever saw. That's working memory. But it must remember where its charging station is. That's long-term memory. AI researchers are now building memory managers for LLMs that actively decide what to keep in the fast brain and what to move to deep storage. This means the AI is learning how to forget. In a multi-session conversation, a persistent agent will prune the garbage, like you complaining about the weather, and keep the gold, like your preference for Python over JavaScript. It's moving from a session that disappears when you close the tab to a biography that grows as you work. This is the difference between a tool you use and a collaborator who knows your history. Some argue we don't need these complex memory systems if we just make the context window bigger. If an AI can read 2 million tokens at once, why bother with retrieval? But there's a catch. Massive windows are incredibly expensive and slow. They also suffer from lost-in-the-middle syndrome, where the AI ignores information buried in the center of a huge prompt. Research suggests that even as windows grow, smart retrieval remains the only way to provide traceability, the ability to show exactly which document an answer came from. There is a catch to all this. When an AI has a long-term memory, it creates a permanent, searchable record of your behavior, preferences, and data. We are shifting from the risk of hallucinations, the AI being wrong, to the risk of data persistence, the AI knowing too much. As these hierarchical systems move from research papers to your desktop, the question isn't just, will it remember? But who owns those memories? We are witnessing the end of the AI's goldfish era. By moving beyond flat RAG and into hierarchical, multi-session memory, AI is becoming less of a search engine and more of a digital twin. It's a shift from processing chunks to understanding systems. The next time you open a chat, don't be surprised if the AI remembers exactly where you left off, not because it's thinking, but because its architecture finally has a place for the past. If you want to see the specific tools building this right now, the links to the research are below.